Okay, we're going to kind of review yesterday's stuff and then we'll move into something new on the next page. So it says the fuel efficiency of a sample of hybrid cars is normally distributed with a mean of 54 miles per gallon and a standard deviation of 6 miles per gallon. Use the mean and standard deviation to label the intervals on the horizontal axis of the normal curve. Okay, so the mean was 54. And then the standard deviation was 6. So I have to add 6 to get to the higher one. So 60, 66, and 72. And then I have to subtract 6 to get the lower ones. 48, 42, 36. Questions on how that's set up? Okay, now I'm going to use that to answer the questions below. Determine the percent of hybrid cars that gets less than 60 miles per gallon. Okay, so here is your 60, and I want less than it. How do you think I want to go about doing that? Yes? Okay, so we got the 50 from the mean lower and then plus the 34% between 54 and 60. So you're right, that would be 84%. Questions on that one? Okay, the next question says, determine the percent of hybrid cars that get less than 66 miles per gallon. Okay, so now I'm doing this whole thing. So I already found that less than 60 is 84%. What do I have to add to the 84 to get the between the 60 and the 66? Very good. Okay, so that would be 97.5%. Questions? Okay, flip it over. So when data values are aligned with integer multiples, so like it's an exact number away from the mean, okay, you can use the empirical rule like we were yesterday and like we just did to calculate the percent of data values less than that value. But what if a data value is not aligned exactly with a whole standard deviation? Okay, so let's consider that same problem with the hybrid cars. The mean is 54 and the standard deviation is 6. What percent of the cars gets less than 57 miles per gallon? Well, so the issue here is that it's not falling at an exact standard deviation away from the mean. You see that? Okay, so, this would have been one standard deviation, and I want to know something that's not falling exactly on that whole standard deviation away. So the issue number one is determining how many standard deviations a data value is from the mean when it does not line up with the increments of the standard deviation. Okay, so how can we determine the number of standard deviations that 57 is from the mean? That's what we want to try to do. So think about it. If 60 is one whole standard deviation away from the mean, what would 57 be? Half a standard deviation. Good. Okay, so 57 is half of a standard deviation away from the mean. Okay, the number that we just calculated is called what we call a z-score. Okay, and a z-score is how many standard deviations away from the mean a data point is. So for a population, the z-score can be found by using this formula. Z equals x minus mu divided by standard deviation. Okay, so z is the z-score. Mu is the mean. X is the data value you're talking about. And S, or sigma, is the standard deviation. Okay, so let's just practice finding the z-score for these following values using that same 54 being the mean. Okay, so from above, 54 is the mean. And I think they said the standard deviation was 6, right? It's that same question with the hybrid cars. So if we just want to find how many standard deviations away from the mean the z-score or the 70 is, we can find the z-score. So z equals, I'm going to put the data value in, so that's 70 minus the mean divided by the standard deviation. Okay, if you're going to type this all in the calculator, that top part must be in parentheses. Bless you. You should get 2.6, so make sure you can get that. Anyone having trouble getting 2.6? Bless you. So what this means is that 70, bless you, is 2.6 standard deviations away from the mean of 54. And even more than that, it's 2.6 standard deviations above the mean. How do I know by looking at it that it's above the mean? Because it's positive. Very good. Okay, so let's look at 53. If I'm going to find that z-score, would you expect this z-score to be negative or positive? Negative because it's where? It's lower than the mean. Good. So 53 minus 54 divided by 6 gives you negative 0.17. So that would be, not very far away from the mean, which it's not. It's pretty close to the mean, and it's right below it. Questions? Okay, flip it over. Calculate the z-score using the information provided. So why don't you guys try those ones? Okay, I gave you everything you need. I gave you the data value. I gave you the mean. I gave you the standard deviation. You seem like foggy. Foggy. Okay, check your answers up here. Negative 0.33 and negative 1.80. Did we get those? Any questions on calculating those? Okay. So issue number 2 is that we now have to identify the percentages of the sections on the normal curve that do not end on a standard deviation interval. So can we find like the percentage that matches up to these z-scores? Okay, so let's consider the fuel efficiency of the hybrid cars again. The mean is 54 and the standard deviation is 6. What percent of cars gets less than 57 miles per gallon? Okay, so it says, can't I just take this 34% that would fall between 54 and 60 and then just say, okay, I'm going to split it in half and get the percent that falls between 54 and 57. Okay, so let's look at this. Do you think that these two bars have the same area? No, right? Okay, isn't there more area in here because it's higher than this one? So together it makes up 34%. It's not 17 and 17. Does that make sense? Okay, so we can't just split it in half. So we can say, no, there is more data between 54 and 57 than between 57 and 60. Okay, and so that's where your z-score table is going to come in handy, and that's the pink thing that you picked up today. Okay, so we can't just say, oh, well, we're just going to say it's 17% there. Can't do that. So for now, let's focus on an appropriate way to identify the percentage of the sample or population that is below or to the left of a certain data point. We have two different ways of correctly doing this. The first is a z-score table, which is what you got. The z-score table always gives you what's lower than the data value. Always gives you what's lower than the data value. Okay, so it's always going to give you the percent lower. To determine the percent of hybrid cars that gets less than 57 miles per gallon, we can use the z-score of 0.5 that we found previously, and we can look it up in the chart. So here's how you're going to look it up in the chart. You're going to go down the side first. This is the 10th place. So we're going to go down to 0.5. One side has negatives and one side has positives. So be on the positive side. Go down to 0.5. And then because it's 0.50, you would just go over to the 0 column and say, okay, my z-score is 0.6915. Okay, so we're going to kind of match them up. So down the side gives you the tenths, and over across gives you the hundredth place. Okay? We'll practice in a second. But what this is saying to you then is that would mean 69.15% of cars gets less than the 57 miles per gallon. Okay, so let's practice. Flip it over. Using the table provided to you, determine the percent of data that's less than 70 miles per gallon. Okay, and so we already found the z-score to be 2.67. Okay, so let's go to your chart. We're going to go to your, you said you put it in here, right? Yeah. Okay, so we're going to pull your chart and we're going to go down to 2.6, and then we're going to go across to where it says 0.7. So I'm going to, here's my 2.6, and I'm going to go all the way across till I hit 0.7 from right here, 0.07. Okay, so that's going to be my value where it matches up. What is that value? 0.9962. Okay, so 0.9962 means 99.62% of the data lies less than 70. Okay, why don't you guys try this one? This one gave us a z-score of negative, what was that z-score? Negative 0.17, I think it was. Yeah, negative 0.17. Okay, so let's see if you can look it up. You're on the other side now. Go to the negative side. Okay, do we need help finding it at all? Okay, it should have given you 43.25%. So if you didn't get that, raise your hand now so Miss Sable can help you figure out what you're doing wrong here. Not 1.7, 0.17. Okay, big difference. Any help? Anyone need help? Okay, so let's put this into practice now. The battery life of a laptop computer has a mean of 16 hours, so there's your mu. Okay, and a standard deviation of 2.5 hours, so there's your sigma. Is the z-score associated with 17 hours going to be positive or negative? Positive, good. Why is it positive? Because it's above the mean. Larger, it is larger than the mean. Okay, and then it says, and then calculate the z-score. Okay, so I'm going to do z equals, the data value always comes first. So data value 17 minus 16 divided by 2.5. Should give you 0.40. Be able to get that? Okay, is the z-score associated with 15 hours going to be positive or negative? Negative because below the mean. Okay, and then calculate it. So z would be 15 minus 16 divided by 2.5. Negative 0.40. Why does it make sense that one of them gave you 0.40 and one of them gave you negative 0.40? I mean, they're the same, just one's positive, one's negative. Why would they be the same? This tells me if you understand what you're trying to find. Because they are what? Equal distance from the mean. Very good. Okay, so this is the same distance from the mean as this is from the mean. They're just in opposite directions. Because this z-score is figuring out how far away from the mean you are in terms of standard deviation. Okay, very good. So the next problem says, what percent of laptop batteries then have less than 17 hours of battery life? Okay, so we're going to look up our z-score for 17, which was 0.40. Look up on table. Okay, 0.4 and then 0. So be on the positive side. Practice looking it up. Practice looking at 0.40. Did you get 65.54%? Yes? If you are not getting this, you need to tell us now because you're going to get everything wrong in the whole chapter if you don't know how to look it up on the chart. So it's probably something minor that we can help you with. Okay, why don't you guys do this one? Look up negative 0.40 in the table. Look up negative 0.40. Okay, wouldn't it be the same as this? Would it be less or more than this? Less, because this is the percent on the normal curve. If this is 16 and this is 17 and this is 15, this percent is everything less than 17. This percent, I'm sorry, this one says more than 17 has to be over here. Okay, everything else. So how are we going to, I'm sorry, I shouldn't have looked this up. I didn't read the question carefully. How are you going to find more than 17 hours? How do you find the part that's not 65.54? 100 minus 65.54. Okay, so that's 34.46%. Okay? So anytime it says less than, you can just look it up on the table. Anytime it's asking for more than a value, you have to subtract from 100. Yes? It would be the same as the point from the negative one, because they make up the opposite. That doesn't always work. It's just because they're in the same distance away. Okay? Okay. That just worked out for you guys this time because they were the same percent. They were the same distance away from the mean. Okay. What percent of laptop batteries have that have battery life that lasts between 14 and 17 hours? Okay, so now what I'm looking for, like on my normal curve, is this area between 14 and 17. Okay, so let's think about this a little bit. If I figured out what percent was less than 17, how could I figure out what's between 14 and 17? Subtract what from it? Remember, the z-score always tells you what's less than it. So if this z-score less than 17 gives you this whole piece, and I don't want this piece, what would I subtract? Yeah, less than 14. Okay, so if I figure out what's less than 17 and then I subtract what's less than 14, I'll have in between them. Okay, so that's kind of the goal. We have to figure out the 14-hour z-score then. So I'm going to do z equals 14 minus 16 divided by 2.5. Okay, and that gives you a negative 0.80. Look that up in the chart. Look up negative 0.80. What does that give you? Good, 21.19. Okay, so that is this piece, 21.19%, less than 14. Okay, now if I figure out the less than 17, which you guys already did above, less than 17 was 65.54%. That's all of this, all the way through, 65.54%. Okay, so if I take that 65.54 and subtract off this, I'll be left with what I'm looking for, which is in between there. So I have 65.54 minus 21.19. That would give you 44.35%. That's going to be this area right here, which is what I was looking for. Any questions? Okay, I'd like you guys to try number 6. Once you get an answer, you can check it with either of us, and then you can pick up your homework. Do it the same way that you did number 5. You just had to find both z-scores because we didn't do both of them yet. It's 30.5. Oh.